morning, everybody. I want to welcome my good friend and the best application level security guy I've ever had the pleasure to work with, Michael Vien. Michael and I have done some work together at Secure Ninja, and I met him out there, and he just blew me away. And what I loved that you talked about was reverse engineering malware and how you can't decompile an application, but you can disassemble it and look at it. But whatever you want to talk about for the next hour or so would be great. Well, any cool stuff you're working on right now? What are you doing these days?
Well, right now I'm downtown Dallas working on an on-site project, which is kind of why I'm in this little box I'm in right now. But yeah, I mean, I've got a couple of different companies. One is the measured risk, where we're doing some risk analytics, risk prediction. And then we're also working on doing, obviously, training and pen testing, incident response, and that sort of thing. But let me, if you want to do something with malware, then let me crank this up, and we can do some quick little deal on malware.
Let me make sure you can share your screen.
That's usually helpful.
Yeah, you should be able to do that.
Okay, so let's see.
I may have to stop my share.
As I'm viewing requests, no, I don't want to. I think you do have to stop your share to give me permission to share or whatever. So while you're doing that, let me find this really quick. I may have, let's see, some slide action here for you. Let's see. Oh, there's the malware reverse engineering workshop. No, let's do. I know I have intro to malware course. There we go.
I didn't give Mike a lot of time to do this. I had somebody else who was going to speak. They had to back out. So I appreciate you filling in the last minute here.
Hey, no worries. Easy peasy. So, yeah, continue. So let's see here. All right, I think we are good. I think I can work off of this. So let me see, where's my Zoom meeting window? There it is. Let's do share desktop. There we go. Now you should see my desktop, right?
Yep.
So, so this is a deck I use for some classes I do for a company called Counterattack. So they actually have a product that was originally HB Gary, and it was the Responder Pro product. And then Mantech bought it, and then Counterattack bought it from them. And ironically, even though Counterattack is supposed to be a malware detection company, they don't have anyone who does malware reverse engineering. And they don't have anyone that does any training on it or even on the product they bought. So they contract me, and I still do training for them. Now, this course that this slide deck belongs to is actually a 4-hour course, which obviously we don't have time for. But what I'd like to do is just kind of go over some kind of the basic stuff that's in here, just as kind of an intro kind of concept of what we're going to be talking about. And then kind of show a little bit of demonstration, you know, some of the information that we can get at different levels and that sort of thing. And I think that would be useful for people. So the first thing that I think that we should show is this. I like showing this slide in the beginning of a malware class, because this is one of the things that I think a lot of people get very intimidated by, right? They see the disassembly and they're like, oh my God, that looks like freaking alien scratch or something. I have no idea what that means. And the thing is that reading disassembly or reading assembly code in general is actually pretty easy to do. The majority of the opcodes, the instructions, are mnemonics, so they basically sound exactly as to what they're doing. So when we look at this one, for example, we got a move, we got a test, you know, we've got an XOR there, which we can explain in a second. We've got a compare, you know, we've got these things that are pretty easy to recognize and pretty easy to understand. Now, writing assembly code is completely different, right? Because obviously you need to understand how to manage your own memory, how the stack works, and all that kind of stuff. And you gotta understand that in order to write it. But reading it is pretty easy. And so I think that from a reverse engineering perspective, I think that almost anyone can really do it, especially if you have previous coding experience and you understand basic, you know, code syntax and those sort of things, the ideas of switches and loops and those kind of concepts. Then I think it's fairly easy to understand. And then, like I said, some of these things aren't necessarily mnemonics. Like, for example, this is an acronym for jump not equals, right? So your conditional jump statements, jump equals here, just a straight up jump for that one. So that one is definitely mnemonic, right? But I mean, most of these things are pretty easy to understand. So, and going through and understanding reverse engineering in general, first of all, I mean, reverse engineering is the idea that we take any object, doesn't matter if it's code, doesn't matter if it's a car, a lock, it doesn't really matter. It's the idea of taking the final product and then trying to break it down into its components to better understand how it was built. And this can be done for a variety of different reasons. And in various different industries, they use it for compatibility to build, build in compatibility. Then we also see it using it for competitive edge. So when, some new car maker comes out with some new innovation, whether it's safety innovation or whether it's, something that's just kind of cool, like even the idea of lane departures and sensors and those sort of things that tell you when you're in your lane or when you're about to leave your lane, or headlights that move with your steering and that kind of thing, right? The various other manufacturers will figure it out. They'll go and they'll reverse engineer it. They'll change something so that it's no longer in violation of their patent or any of their, copywritten data or anything of that nature. But, but they reverse engineer it to figure out how it works so they can put it in their cars and so they can be competitive with the same features of some other car manufacturer. So it's the same idea in doing reverse engineering with code. People have reverse engineered, for example, the entire Microsoft operating system, the Microsoft Office documents and that sort of thing to be able to build things like OpenOffice, or to be able to build in compatibility and to be able to allow you to write code with the same level of understanding of the operating system that Microsoft has. Because Microsoft, for example, publishes some of their APIs, but there are a variety of APIs that Microsoft publishes that are typically called the native APIs that Microsoft never published. They're out there. Microsoft software uses them, but they didn't publish them normally for other developers to use. So other people have reverse engineered the kernel, figured out what these APIs are, and then have documented them for you to use in Microsoft coding and that sort of stuff. So, like I said, we're going to be working today primarily with Responder. There's multiple ways of doing malware reverse engineering. The original, like the sort of generally accepted methods are either doing a static reverse engineering or dynamic reverse engineering. In static reverse engineering, and we can kind of look at the examples here, is that, go away. So when we look at something like static reverse engineering, so we've got some stuff open back here. Let's get rid of this stuff. We don't need this stuff right now. All right. So if we look at something like a Trojan Horse, like in this case, Beast Server, right? So basically I use this Beast Trojan Horse here. This is the client side of it, right? To build a server, and it gives you all the configuration options and all that. And if you want, and Larry, you can tell me if this is interesting or not, we can actually walk through like how to build the server and what the functionality of this Trojan Horse is and that sort of stuff. And I don't know if that's necessarily in scope for this, but if you want, we can do that.
It's just that, and I warned him that you have a tendency to not track the clock, and I do need to be finished at 1, but I want to let you loose, and because I love the way your brain thinks, and I don't want to restrict you other than time. So whatever you feel works great.
Okay, so yeah, so first of all, what this is a Trojan Horse. Now, Trojan horses, of course, are named after the Greek and Trojan War, which I'm sure all of you are familiar with. But the basic idea of this is that in this particular case, this Trojan horse was used by a 19-year-old kid who wanted to be a day trader, right? Trojan horses are often written by someone, published onto a website, and not really disseminated by the author. They're usually downloaded by someone else, and then that someone else uses them to infect other computers, which is why you rarely hear of Trojan Horse authors being arrested for writing the Trojan Horse. Now, they could get arrested for doing other things. For example, this is another Trojan Horse sub 7, and an employee of mine, Modman, aka Greg Hannes, wrote sub 7 and all of its variants, and was never arrested for writing sub 7, right? He was arrested, but he was arrested for hacking Verizon, which was entirely separate.
Wait a minute, now that's like one of the oldest Trojan horses. Isn't that a 90s thing? When did sub 7 come out?
Sub 7's been around since the 90s, yeah. But I mean, there's a variety of different versions of sub 7. I mean, I have here, let's see, I don't know, I've got like downloads here. I think I've got sub 7 somewhere in here. where's my sub7? Move it. Sub7. That's one version. So these are all of the versions or whatever. Or I have a bunch of them in here, different versions. I think I've maybe already put them up on Dropbox. But yeah, I basically, yeah, there they are. So this is all of the sub7 versions, including a sub7 Zeus combo type of a thing. But yeah, so like I said, Greg is an employee, so I made him give me all of the source code and everything for sub7. But yeah, but sub7 is an old school Trojan horse, and the point is that the only guy that I know of that was ever arrested for creating a Trojan horse was the guy who created SpyI. And the only reason he was arrested was because he built in specific functionality in his Trojan horse to steal banking credentials. And he was working with a guy who was actually deploying the Trojan horse and actually collecting those credentials. And he was working with that guy, and he was, the guy would come back to him and say, yeah, could you add this? Could you add that? So it was that ongoing sort of conspiracy to build functionality to steal banking data that ended up leading to his arrest. And he was charged with conspiracy charges, not necessarily direct charges for fraud and those kind of things, but conspiracy to commit fraud and that kind of stuff. Anyway, in this particular case, the 19-year-old kid downloads this. He doesn't write it or anything like that. And so you can kind of see, like, this is one of the dangers of Trojan horses, is the idea that, first of all, that anyone can really download them, right? It's not like a virus or something like that where there's just some repository where you can go out and just download viruses. I mean, technically there are those out there, but you have to be kind of careful to kind of know what you're doing in order to do this. The great thing about a Trojan horse is that it is non-replicating, non-propagating. So it doesn't by itself try to make copies of itself, and it doesn't try to move itself to other machines. So it just, works on the one machine. So they're fairly safe for people to download and to kind of play with and do what we're doing here with them, because it's not really going to have any persistence or any sort of real permanent damage that it does to the computer, or it doesn't remain infected in the computer, right? So either way, the first thing we see here is we got this beast Trojan, and like I said, this is the client-side interface, and so we would hit build server. And in the case of the 19-year-old kid, he actually downloaded this Trojan horse and downloaded a stock tracking tool. So he downloaded a free stock tracking tool, then he combined the two together, and I'll show you how to do that here in a second, but he bound those two together, and then he posted it up on some sort of a forum for day traders, right? So people would go there, and he said, hey, this is a great stock tracking tool, you should download it. So a couple of people did. He used it to steal their credentials to their brokerage account. I don't know what brokerage it was, but whatever it was, he got the credentials for that brokerage account. He then used it to used other people's accounts to buy, say, I think it was around $90,000 worth of crap stock that he had that he was trying to get rid of. It was easy to catch him because basically, if you woke up in the morning and you realized 30 grand was missing out of your account, you would call your brokerage and you'd go, what happened? And they would go, oh, you bought stock from this kid. And they went, no, I didn't, right? And so the guy was arrested. The 19-year-old kid was arrested and charged and convicted. And the funny thing is once he got out of jail for his initial conviction, he actually went back and did the same thing with the same Trojan horse. He went and downloaded Beast and used it for that reason again. But anyway, the point is that you can see how easy it is to configure. We've got options here like direct connect and reverse connect. Direct connect would obviously open a listening port on the local computer, and then you'd have to be able to connect to that computer from the internet. So because of firewalls and those sort of things, we have reverse connect. Now, reverse connect, of course, will call outbound from the infected computer out to the internet. So assuming there are no egress rules, which most organizations don't have, this should have no problem. But the problem with this is, of course, that in order to do a direct connect, we have to give it an IP address, which means that there's a value that if it is investigated by law enforcement or any incident response team or whatever, they should be able to figure it out and find out what that IP address is. And again, 19-year-old kid didn't do anything to hide his IP address, so it was connected directly to him. Of course, if you were a real hacker or whatever, if you were really trying to do this, you could have other machines you've infected on the internet that work as a proxy. So this would connect to those machines, and then you connect to that machine, and that's how you would get your data. Anyway, then we have my favorite here, which is the svchost.exe as the executable name for this particular malware. And why that's particularly interesting is because for whatever reason, if you look at an uninfected Windows machine, you'll see that Microsoft has chosen that the services host process, which is what all these are, actually there's already one Trojan Horse process already running. Don't know why that's currently running, but we'll end it. But anyway, so we see that all these services host processes here are legitimate copies of the service host process, right? And this is, for whatever reason, Microsoft has chosen this as a to run basically everything from DHCP configuration to DNS resolution to everything else. If you were to run a web server on this box, it would run the web service. I don't know why they chose to do that, but for whatever reason, it's a great thing for a hacker because we can sneak in another services host process, and the average user isn't going to know what it is. And even if they were to suspect it and were to Google it, trying to see what it was doing, they would still get, you know, an answer saying, "Oh, that's normal. This is a normal Microsoft service process or whatever," right? So if you were to go here and you were just to say Google, you know, the svc host.exe, trying to see if that was potentially something malicious, right? It would go, "Oh yeah, no, that's a generic host process for Windows 32 services. You know, it's an integral part of Windows OS." So the average user would go, "Oh, I guess I shouldn't worry about that. That's normal. I'll just leave that alone," and they would leave it alone and walk away, right? So naming it, it's a good idea. Then we have injection. Now this is straight up DLL injection is all it's doing. And so you can see it says either no injection or inject an Internet Explorer process, Explorer, or Notepad. We have notifications, so signal initial infection, email, ICQ, for those that may be too young to realize, is an old school chatting protocol. CGI is obviously for web. We've got startups. Now this is where we do persistence. Now normally we would expect to see persistence going into the registry, like the run once keys, the run services once. That's where we normally expect to see persistence. But in this case, they chose to do the COM services key and an ActiveX control. Now, ActiveX controls, of course, work within the Microsoft operating system as well as in the Microsoft browser. And so this would get started whenever the operating system starts and it loads the ActiveX controls. We've got kill, antivirus, and firewall on start, and you can see this is just a list of process names. So it just basically looks for any of these potential security processes and attempts to kill them. And the idea here being that if we were able to land on the box because it wasn't detected by antivirus initially, we don't want them to update their antivirus and get a signature that may detect this virus. So we put it in here and say, you know, we're gonna kill it as soon as we land on the box. And then we can check every 5 seconds to make sure those processes stay dead. And we can also disable the XP firewall. Down here we have some things that may not be as self-explanatory. Melt server uninstall is the idea that the original file that's dropped on your system gets deleted, gets wiped by the Trojan Horse process, and it creates a copy of itself that is a random name. And the reason for this is so that if the user does at one point figure out, hey, maybe that stock tracking tool that I downloaded might have been infected, and they want to run it up to something like VirusTotal, that they could run it up there and see it. So obviously we want to delete that so that doesn't happen. Enable keylogger makes sense. The XP restore points are actually Microsoft's solution to the blue screen of death. So the blue screen of death was that you know, error that would whenever any sort of kernel panic or anything like that happened in the Microsoft operating system, it would trigger that blue screen and it would do a data dump and kernel dump and all these other kind of things. Well, they decided that this XP restore point was basically a snapshot, kind of saving the state of the system whenever you install new software or new drivers. And so the idea would be that if the screen or it panicked or went to blue screen, that you could go back to this restore points, basically that snapshot, to before that software, that driver was installed, and then it would allow you to do that. Well, obviously we don't want them to restore to a previously good point before our Trojan was installed, so we just delete those and keep that from happening. The open port online only is actually a call to an API, which is API function, which is get internet connected state. And the idea in that is just to see whether or not you're actually connected to the internet, not to the network, not that you have an IP address, but whether you actually have access to the internet. And the main idea here is it's a kind of a weak attempt at stopping sandboxing and that sort of like automated analysis of malware, right? Because when people put it onto a VM and they have the VM completely isolated, it obviously doesn't have internet connectivity. And this would tell them, hey, don't act, don't do anything, don't open a listening port, don't try to connect outbound, don't do anything like that, unless we have real internet access. And so that's the main goal there.
What test does it use?
Take care of message.
The internet.
It's an API call. It's called get internet connected state, and it's just a normal get connected state.
I just checked to see if I can connect to Google. But I'm just curious because I know like FireEye does that. If FireEye will sandbox a malware or a suspected piece of code and then attempt to run it in a sandbox environment. And something like this would be a way around it because one of the things they look for is trying to phone home. And if this isn't phoning home because it's not
right. Yeah. And this is the function call. So it's just this call to internet get connected state, and then as you can see, it just returns how you're connected, if you're connected, if it's using a proxy, if it's using a modem, if it's using the LAN, that sort of stuff. So this is what this function returns, and it basically tells you whether or not you have an internet connection. So it's an actual API call, and it's just a simple thing to do, just to see if you're there. Now we also have the extended version here, which has a couple other pieces of data in here, but they're not using that call. But still, these are just the extended. This is the ASCII version, the wide Unicode version, right? But anyway, the point is that but the point is that that's the function it's using for that. So then we can obviously pop up different fake error messages. The application is failed to start because this OCX wasn't found. Try reinstalling it. Basically giving a reason if the bound program, the legitimate program that you're attaching this to, for some reason doesn't work, then you could throw an error. You can also delay execution. So to Larry's point about sandboxing and those sort of things, this is another attempt to defeat that kind of automated detection, in that it basically says that you won't start the Trojan Horse process until a couple of restarts or after a specific date. So you could try to wait, a couple of days or a couple of weeks or however long to actually start to behave maliciously, basically. And so that's the idea here.
That's awesome.
And so then here's the binder. And so the binder, all you have to do is just add whatever your legitimate file is, right? So you would find, like in my case, I just copied calc over from System32, and then you would add in your server process. So you just go down and find your server, and then you would do that. And then it automatically chooses the default icon from the resource section of this file, right? Grabs it and puts it over here and says this could be your icon. But if you wanted to choose a different icon, you could, of course, find any executable file on your system, and you could use the icon pulled from the resource section of that file. But there's a variety of resources that you can do to change icons, but it's usually better just to stick with the one that came with whatever process you're binding it to. But you bind it together and you end up with a file like this. Now, all this is doing is taking the Trojan Horse file and the legitimate file, compressing them, storing them into the data portion of a third file, which is our new file. We send that to the user. The user then opens that file. It executes the legitimate process, the stock tracking tool, in the case of our 19-year-old kid, opens that up in a visible window, and then it extracts and executes the server process, but it does that obviously in a hidden window, so it wouldn't be visible to the normal user, right? So we can start listening here, and we can just run this server service. We can kind of see, like, this is the notification you get. It's a little alien head pop up down here in the lower right, and you would get a little alien head here in this box. You double click on that, now you're connected to it, right? So the functionality that it has, you can see, for example, the file manager. So what this gives us is access to every file system the end user has access to, which would mean any local file systems, any file systems they have network mapped, any thumb drives, CD-ROM, DVDs, anything that they put in, Blu-ray, whatever, anything they put in. And additionally, if they have mapped any external, like cloud-based drives, so for example, here in my file system, I have mapped, you can see here, I've got Google Drive mapped, I've got Creative Cloud mapped, I've got Dropbox mapped, right? I have OneDrive mapped, I have the iCloud Drive mapped, right? So I've got all these different cloud-based file systems that I have mapped to my local file system, which means that if I were infected with a Trojan Horse, they would have access to those as well. They'd be able to see all those file systems as well. And you can see, you can upload, download files, rename files, run as hidden, change the attributes of files, delete files, erase all the files, and all that kind of good stuff. So you've got pretty good control over the file system. We have access to the registry. Now the registry, of course, you guys should know, is the hierarchical database created by Microsoft to store all of the configuration and startup information for both the operating system as well as all the applications installed on that operating system are stored in here, right? So there's also potential for usernames and passwords that can be stored in the registry. There's definitely things like serial numbers and keys and that sort of stuff to register software, and those kind of things can be here. So it's going to be useful treasure trove of a variety of information that can be used in there. The screen, we can see the remote screen through here. So this is just like any RDP connection. So it gives us full access to their screen. It is clickable and draggable, so you can, you know, go in here and select, like for example, we can select, let's see, something that doesn't cause a whole big problem. I'll just do this mandiant text file. So you can open up a text file from in here. Now, obviously, if you're doing this kind of stuff on someone's screen, and because we're on the same machine, you're seeing this like lovely infinity window happening. But obviously they'd see those things happening too, right? So you want to make sure that, you know, if you're going to be manipulating the screen, you're doing it when they're not sitting at their computer. I don't know if I can do this because I'm on the camera with Zoom, and I don't know if it'll let me. It doesn't seem like it's going to, but yeah, it's not showing it. But normally if I had the webcam associated in here, you'd be able to see me sitting at my computer like you're seeing me here on Zoom, but you'd be able to see that showing up in there. And you'd also be able to save these. So this is, if any of you have ever watched Mr. Robot, right? And I don't know if Larry has told you about Mr. Robot, but if you haven't watched Mr. Robot, it's one of the most technologically accurate portrayals of hackers ever done for TV or movies.
You know, our buddy Ralph said that he helped start that.
Yeah, Ralph Echemendia. Yeah, he's one of the technical advisors of Mr. Robot. But yeah, so they get a lot of like actual people from the security industry and that sort of stuff to advise the show, which is why it is so technically accurate. But yeah, but there's a scene in the first season, and this may be a spoiler if you haven't seen it, but still it's not that big a one, where the guy gets tricked into installing a CD into his computer that has a Trojan horse, and then the Trojan horse then uses the webcam to monitor. He sees his girlfriend taking a shower behind him, plus the guy's having an affair of I guess against his girlfriend or whatever. And so he gets some of the mistress's photos as well, and then uses that to blackmail the guy into installing the same thing into his work computer so that they can then own the work computer and everything. So, but that's the premise of this, is the idea that with this remote webcam, not only could you obviously see if your victim is sitting at their computer and then determine whether or not you wanted to do something that may be visible to them, but you can also use this as a way to collect other information about what's going on behind them, right? So for blackmail purposes or other useful information. Apps, we can see their apps. Processes is a better list. It shows us all the processes that are currently running. We can, of course, kill any given process we wanted to kill in here as well. Then we have, you know, services. We can see different services, whether they're started or stopped, and we can, of course, start, stop, or disable different services. So if we see like an antivirus service or something, we could just go in there and say disable, kill the antivirus service from here. We could also use it as a way for persistence. Clipboard's handy because this shows us what's in the actual clipboard. So if people think that they're, you know, oh, I'm going to do keylogger because I'm going to use a key or, you know, some sort of password safe or something like that, and so I'm not going to have to type anything, so you aren't going to get in the keylogger. I'm going to copy and paste it. Well, I can see your clipboard, so I can still see the password that you're trying to copy and paste. This was last compiled in, I think, 2004, and so you can kind of tell because it has like dial-up passwords and other weird shit that nobody uses anymore. So then under Windows, we have the ability to hide, crash, power off, reboot, shut down, log off, given users on the machine, which if we may need to do if we install, say, a rootkit to hide the presence of this Trojan horse, then we may need to reboot the system. Now this stuff is called lamer stuff, primarily because doing things like hiding their desktop icons or their sys tray or something like that would be very good indications that they've been hacked and that their computer is now owned by someone else, right? And so it would trigger an investigation and that sort of thing. And so you probably wouldn't want to do these kind of things, right? Some of the fun stuff is similar. The idea of, let's say, for example, opening up a browser and you just put an URL in here, and whatever URL you put in, it'll open up their default browser and take them there, right? So you could do that as a way, I guess you could use it as a way to mess with some guy you don't like at work. You could wait until the boss goes into his office and then open up his browser to some like bestiality site or something like that and try to get him fired, I suppose. But then you could change the wallpaper and open up this like Neo style chat window where you can say, you know, like, follow the white rabbit, Neo, or whatever, right? But then we have things like the server stuff here to update, close, kill the server. We've got a port scanner, so we can scan from our infected boxes to see if there are other boxes we may well infect. We can pop up other error messages and that sort of thing. We can run commands on the command line and get the responses directly into here so the user doesn't see it. There's 2 keyloggers built in here. One is a file-based keylogger where it writes all the keys to a file, and then you can get that log file, decrypt the log file, and see it. Then there's also the live keys. So what this does is sends the keys as they're being typed from the victim's machine to the hacker's machine. So the idea here would be that, say we're going to a banking website and they were putting in their credentials, right? And then they put in, whatever their password is, right? And we see that the password is showing as being obfuscated here, but when we go back and look at the actual key, we see that, not only does it tell us that these were what were typed and that they're in clear text, but it also tells us exactly what bank they're at, right? And that they're in the Firefox browser. So a lot of times you'll see books and other people that'll tell you as a way to defeat keyloggers, they'll say, well, what you should do is when you're typing in your password, you should type in the first few characters of your password here, then you should switch over to, Notepad, you should type in some gobbledygook, and then you should switch back over here and type in a couple more characters of your password, and then type in gobbledygook. And their theory is that for some reason they believe that keyloggers are just writing a stream of keys, right? But you can see that because this is context aware, we can kind of see that, oh, there you were in Notepad, then you were over here in Bank of America, then you went to Notepad, and then you're back here in Bank of America. So then all you have to do is just go, oh, your password is PASS, right? And stitch it together, and they know. So it's not, that's one of the things that I always like to point out is that, keyloggers are a little bit better than the way that most people portray them as just showing a random series of keys, which wouldn't really have any real value or use. We also have some other stuff in here where we can set a password and we can, change ports and that sort of thing that it's going to listen on and do all that kind of good stuff in here. But basically that's it. That's the Trojan Horse sort of demo. And then you can, and just so you can see, when we look at the task manager here, this is a 32-bit Trojan, and this is a 64-bit operating system. So the first indication that this is not a valid services host process on this host is the fact that it's running in that emulated 32-bit mode, right? So that's what that star32 stands for. Then we also see that all of these other instances of services hosts run from either system or as a service or something like that. This one's running as a local user, so there's another indication. Also, when we look at the description, we see that over here, we've got a consistent description for these, and this one is inconsistent. So and by the way, this is a simple thing to fix, to go into the actual code and change that to make it so that it does say host process for Windows services. But, that's a thing for a different day to show you how to do that. But either way, so let's show you what the difference between static analysis. So static analysis is the idea that we're not going to detonate the code. So we're not going to actually try to execute the code, and we just try to see what we can figure out directly from the file system itself. More random person here, but I'm supposed to be in.
I believe those are testable terms, guys, by the way. Static analysis versus dynamic analysis.
Testable term for what? For CISSP?
For CISSP.
Or for CISSP? What are you teaching right now, Larry?
Okay. It's a CISSP.
Yeah. So, but yeah, the static analysis, like I said, is the analysis without having to detonate the code. And so this is IDA Pro. This is a freeware version. But basically, you can see that this is how IDA disassembles. Now, IDA shows it to you in this format to basically give you kind of a flow of execution. But one of the things that I want you to notice about this, and this is something that you can, if you ever go to do your own disassembly and those kind of things, one of the things that you should notice is the fact that it has no strings in the strings window. So the very fact that we don't see any strings in the strings window. Now, IDA is smart about strings, okay? So if we were to take this server process, let's say, for example, and I don't know if this server is one that I've messed with or not, but we'll just take a copy of this one, and I'm going to move it over here to my Mac OS. We'll just go to downloads. We'll just paste in there. Okay, and it's telling me we'll just replace that one. All right. So now what I want to do here is, so if we just do strings on that server process, right? And we'll do this to less so we can kind of see it. What strings does, and this is part of static analysis, by the way, what strings does is it basically looks for at least 2 ASCII characters followed by the ASCII string terminator, which is a null. And null may also be a test question. I know it is on the CH as a string terminator. But for Unicode, it will look for the same thing, 2 Unicode characters followed by double null, which is their string terminator. And so you see we get a lot of gobbledygook in here. So you see we've got, you know, this program that's run under DOS or under Win32. This is the standard DOS stub warning here. We see we got a couple of UPXs in here, which I'll explain in a second. But then there's just a lot of garbage, a lot of gobbledygook until we get down into here a little bit. And then we see, like, down here at the very bottom, we have a bunch of what looks like actual words, right? Now, what we're seeing here is actually what's called the imports table. So all executable files in the Windows operating system are in what's called the PE file format. PE stands for portable executable. And in the portable executable file format, so that's all EXEs, COMs, DLLs, and sys files are all PE. There is the header, and then there are various sections. Now, the header obviously has information about how much memory the process needs. It has the information about how many sections there are, what those sections do. There's a checksum. There's a variety of other information. But basically, there's a thing called the imports table. The imports table says that if we're doing, so there's 3 types of linking in writing code for any type of code. So there's dynamic linking, static linking, and runtime linking, right? And so when we do dynamic linking, it's basically when the OS reads the header, the PE header of an executable, it reads that imports table and it goes, okay, I'm going to allocate you some space. First, it memory maps the executable, and then it says, you know, I'm going to allocate you some memory space for your heap and then later for your stack. And then we're also going to read that imports table, and we're going to go ahead and load any of those DLLs. So all these DLLs mentioned here, we're going to load these DLLs into memory, which they're already loaded into memory, and they're going to be referenced by what's a thing called the IAT, the interrupt address table. And that's where the operating system says, hey, this is where these DLLs are loaded, and then any additional functionality, which these are the functions that are being loaded from those DLLs, right? So it basically says, here they are, and it gives you a table and it points to where you're supposed to call them. So this imports table is what we're seeing over here in IDA. If we go back and we look at IDAProbe, and we have an actual imports tab here, and that's where we see those same values. So we see here's the DLLs that were loaded from that list. Here's the actual functions that were loaded from that list, right? But IDA took them out of strings and then said, okay, these are actually the import tables, so we'll put those over here and we'll leave them on string. And then notice it said that none of the other strings does it consider an actual, like, valid string, so it left it completely blank. Now, why this is happening is because, and that's where I'm going to go back to this UPX part, is that we look at the top of that file, we see that it is UPX encoded. So what UPX is an open source packer. So a lot like the binder utility, a lot like the binder utility, I keep hearing some weird sounds.
That's not you?
Yeah.
Let me see.
No, that's not me.
Okay, let me see who else.
I think it's Pradeep is unmuted, so if you want to mute him, yeah, there we go. All right, so, but anyway, so the idea of the UPX packer is that it takes and it does kind of like what the binder does. It compresses the original malicious code in our case, and then it stores it into the data set portion of a new file. Now, when that file runs, it does the same thing as the binder does. It extracts the original malicious code file out, but it changes the signature of that file. Now, antivirus isn't fooled by this because antivirus can see these UPX headers as well, and then it goes and it does what we're about to do, which is basically it just does the UPX. It downloads the open source. It's open source, as I said before, downloads the UPX, and this does the UPX on the server, right? So then it unpacks that file, and then it just does its signature based off of that. So we're going to look at the difference of the strings once we unpack it. So once we unpack it, we see we got now these labels here that we're seeing that we didn't see before are the labels of the actual sections of the PE file. Then we see a bunch of these strings, which may or may not be. These could be some sort of a format string type of a string, but don't know. But a lot of this is still gobbledygook. But then we see we've got a lot more stuff going on here. There's some more functions that are being exposed here. Then we're seeing some stuff in here, like for the hello mail recipient to data from subject, all these things which are clearly being used for, you know, sending mail, probably for the notification portion where it's supposed to notify you via email, but it could also be used for some other potential attack vector in there. Then we have like get screen, get webcam, which we already know what those do. We've got a couple of registry keys, some other strings. So we've got a lot more strings, is my point, than we had originally. As you can see, as we scroll through this, we've got a lot more than we originally saw. So this is kind of the problem with static disassembly, is that if we don't realize what we've done here is all we've done is a disassembly of the UPX executable portion of that file. So we don't actually have the malware here, right? And as I said before, the empty strings window is usually a strong indicator that you're either dealing with a compressed or possibly an encrypted file. And so that's why you're not getting any actual strings in here. And so this is one of my reasons why I don't do a lot of static disassembly, because if it's UPX, we can just do what we did. We can just download UPX. We can do a decompress.
Break it up there. Uh-oh.
That's
frozen.
Using the UPX -D, and then we can load encryptor, or are you back? But if it has its own packer, or
Mike, you're
someone has written their own one,
intermediate connectivity.
then in that scenario, okay. I'm on my phone. I had to tether my phone to do this because the corporate network in here, whatever, is kind of jacked. So you know, they block things, and I didn't know if it would block Zoom,
No,
so I did it on
I can
my phone
appreciate
tethering,
you
so.
being responsible to your customer there. Actually, I'm impressed with the phone tethering doing so well.
Yeah. Well, Zoom's got really good compression ratio on their video too.
It's amazing. A 500 meg file, if I try to bring it into Microsoft Movie Maker to edit, becomes 5 gigs.
That's ridiculous. Yeah. So yeah, their compression is pretty amazing. But anyway, the point is that when doing static disassembly, you have a potential hurdle that you have to come over, is that if they did use a cryptor or a packer that isn't open source, then you have to, if you're doing static disassembly, you have to go through the code to try to reverse engineer the packer or the cryptor first. And then you have to basically do it to a level to where you can recreate that packer so that you can then get out your clear text file so that you can actually see the malicious code underneath it. That's one of the reasons why static disassembly is safer, in the sense that you're less likely to infect yourself when trying to do an analysis of malware. It has those hurdles that if the file is compressed or encrypted or any other type of security measure that they may have put into it, it could slow down or even completely prevent you doing that without having to reverse engineer and rebuild those unpacking or decrypting routines, right? And so that's kind of one of the main issues with doing that, is the, you know. So then if we go to doing dynamic disassembly, which is the second stage of dynamic analysis. Dynamic analysis would be the idea that we're actually detonating the malicious code in a virtualized environment, so something like this, and then we're using something like, where's my Ollie debug? So then we're using something like Ollie debug or something like that to attach to the process. Now, we can also use something like procmon. So procmon is a process monitor. It was originally created by sysinternals. Sysinternals was bought by Microsoft, but Microsoft still offers them for free. But sysinternals has a variety of different monitoring solutions. They have procmon, which does everything, kind of does file, registry, network, and process monitoring and everything. But then they have individual monitors as well. So there's like a filemon, a netmon, a regmon, and those kind of things. So where you can sit there and actually break out and look at those individual actions, like what files is it opening, what is it doing to those files, is it reading to them, is it writing from, well, reverse that, writing to them or reading from them, is it you know, is it just creating a mutex files and those sort of things? So it can track that, but then you also have it all in the one procmon. I tend to rather use the one large procmon than the individual monitors if I'm going to be doing that, but regardless. So let's see here. What did I do with, there's netcat. There's Ollie Debug. All right, so with Ollie Debug, this is a debugger, and as you can kind of see, it's just opened up all these happy windows in here. But if we want to, we can just open a file. So we can just say open like desktop server, for example, and it tries to execute the server, right? And then what it does is it sets a breakpoint, and it sets a breakpoint right at the initial execution, right at the start of code. And so you can see it's paused right now. It's showing pause. And it stopped right at the start of code. Now, what we can do with this is we can just start stepping over and stepping through the code and just walking down from top down. But the idea here would be that if we believed because of our static disassembly, we believe that we have some sort of a packer or cryptor or something like that, what we can do with Ollie Debug is we can cycle through that process, find and set a breakpoint for wherever our packing code happens to be, right? We can set a breakpoint for that. We can basically just step over and keep cycling through to our breakpoint until it builds out, because the unpacking is going to build out in memory the entire unpacked original malicious code, right? So then we can take that and then we can go and do a disassembly on that and try to figure out what the actual functionality is doing from here. But this is the view of doing that sort of statically, or I mean dynamically rather. Now the problem with this is that we do have to, see this, Larry? I'm skipping my jiu-jitsu class for you.
I didn't realize
the problem with doing this.
So I knew you were doing Aikido, third degree. Last time I spoke to you, you were third degree black belt in Aikido.
Yes, yeah, still Sundom. Yeah, Aikido. Yeah, but yeah. So I've been doing jiu-jitsu for the last few years, I guess, 2 or 3 years now, and it's primarily for me for exercise. So
Sure.
it's just a method of exercise, but it is nice to know, nice to have some ground skills as well. But I disagree with their sentiment in jiu-jitsu that all fights end up on the ground. I'm like,
I totally disagree with that too. In street fight, they ended with a sucker punch. That's what I always say. And it's always some type of social engineering. Hey, what time is it? You look down at your watch and you get suckered. That's how most fights end.
Right. Yeah. Yeah. And I they always, that's their kind of go-to, I guess, marketing campaign is, hey, all fights end up on the ground, so you need to know how to fight on the ground. And you're going like, I don't know if I agree with that. And you had an interesting story about going to the ground once and getting clocked in the head with a motorcycle helmet. So
you remember that story? Yeah, I didn't go to the ground yet, but I did. I did go to take them down. I was doing jiu-jitsu at the time, and I got in a little scuffle with 3 gentlemen on motorcycles. And when I went to take the one guy down, and I did, I successfully took him down, but his partner hit me over the head with a motorcycle helmet. I stayed on my feet. They actually ran away first.
Yeah, but I mean that's my point though, is that jiu-jitsu I think is it's good in theory, it's good for sport like MMA, but I don't think that it's necessarily good in a street fight, because street fights are never fair. They're never one-on-one. They're and once you go to the ground, you're kind of stuck with that one guy, and so if any of his buddies come along, you're kind of prone to getting smacked. Tom. Anyway, the point is that
Tom turned 70 and he still spars every Sunday.
Wow, that's impressive. Yeah. I hope that when I'm 70, I'll even be able to move spar. I'm so broken. It's so bad. I don't know.
While we're on the subject, I just thought it was something that I'd like to share with the students, and maybe with you. You might know. So I call my my class, Joe Louis told us, don't teach Joe Louis style, make up your own style. So I kind of part tongue in cheek called it cyber kung fu. And Tom threw us a new name and said, we should come up with a program and come up with ways to get black belts in it. And I said, I don't know exactly how to do that. So we never really awarded Tom, and we were considered the black belts. But when we met you, Tom said we should make Mike a cyber kung fu black belt. So you are the only person outside of me and Tom who are blessed by Tom and myself as cyber kung fu black belt. So it's been really, we're both.
I need a certificate. I'll hang it on my wall.
There you go.
Yeah. Well, I mean, the thing about it is like, I like that idea. And there's actually a corporate training thing called Six Sigma or whatever.
Sure.
Sigma 6.
Six Sigma. Yeah, we talk about.
They do belts. Yeah,
Yeah, they have green belts and black
yeah.
belts.
So yeah, so I mean, you could do the same kind of thing, and I mean, all you'd really have to do is just make up a certificate and then buy, you know, a belt for $7 or whatever, and
That's
hand it
just
out to
more
people.
time that
They don't
I'm
even
not
have to
playing my
wear it. I mean,
ukulele. That's just more time I'm not making music and goofing around, and I just can't find that time. You
do you want me to play a couple of your karaoke videos from that
know? No,
place
no.
in
Mike and I used to work together a lot in Washington, you know, Beltway area, and I had a thing for going to this Vietnamese club where they had karaoke, and I would get maybe a little drunk and sing some karaoke. But no, please don't play
a little
that.
a little drunk. Yeah, yeah, we could. I got a few of the. Oh, you want some? Eddie says he wants it. Eddie said, please share. So I have them somewhere. I have like a bunch of probably like maybe like a dozen different
Mostly
videos
James
of
Brown and Frank Sinatra. What a combination!
you did some Elvis. I think I have one of you doing an Elvis song.
Yeah.
Actually. I think it's "Love Me Tender" or something like that. I'm
Hey, I want
not
to get
sure,
back on the. You
but
really
yeah,
today. The
I've
thing
got
I'm
videos
most
somewhere.
puzzled with is that test to see if you're internet connected. So when people are trying to do the dynamic analysis, if it's not connected to the internet, it won't execute. So a sandbox environment protects it. Is there a way now, if we knew what the test they were running, for the sandbox or for the analyst to simulate that they're connected to the internet without actually connected to the internet? So I'd like to know what tests they're running. Does that make sense? And Mike's frozen a little bit there. Hopefully I'll come back. You can't leave me hanging. Did you catch that, Mike? Uh-oh. We lost him.
Okay, sorry, I lost you. I'm back again. You were saying so. Oh, I'm back. Can you
Yeah, I
hear me
wanted to
now?
see if there was, I can hear you. I don't see your screen, but I see your video. But I mean, I see your screen. I don't see your picture, your video, your camera. What I'm concerned with is for the dynamic analysis for the sandboxing environment, I want to be able to simulate that we are internet connected without actually being there to fool that Trojan test to see, you know, don't
Right.
malware. I mean,
Well, there's a solution called INetSim, which does exactly that.
there you go.
So what it does is, regardless of any DNS queries that you make, it resolves them all back to an IP address that you specify, and whatever the IP addresses they connect to, it redirects them to whatever box you tell it to go to. So it actually does sort of simulate the idea that they are connected to the internet, and it's a good way to do your, if you're doing dynamic analysis and you want to make sure that you capture any network connectivity attempts, then you can see those by using the INetSim.
Yeah, because my way, I like to go to Google News and refresh that news. And if I can't refresh, I'm not connected to the internet. I doubt the malware goes through that. That's a lot of traffic to generate. So if we know that what they're doing is whatever, making some call to some website that they usually use or whatever it is, to know that it's a live internet connection, not just an IP connection. So if we could simulate
Right.
that before, yeah.
Yeah, that's what INetSim does. Yeah, that's the whole point of that solution.
Awesome.
So let me just, because I mean, it looks like we're running low on time here. Let me just show you really quick what Responder looks like. So Responder, this is Responder, and so you can kind of see that in doing Responder, and I do have one that's the same process, the same Trojan Horse process, but it'd take me a second to open it up. So I just want to kind of show you, like, so for example, all of these ones that are colored are the ones that are considered malicious here, but I just want to go to one of these and just show you, like, so you can get strings here. So it does strings. Now, what I like about this tool is, besides the fact that I helped write it, which kind of makes me a little biased, but the problem, the thing that I like about this tool is that it doesn't just show me the strings. It shows me strings, and so we can see that we even still get gobbledygook sometimes in here. But the other thing it shows me is that because it does the disassembly, so we can go over here and we can look at this binary, for example, and kind of show you how it shows you the disassembly. So it not only shows us at the top here, this is the digital DNA string. It also gives us a couple of hashes. This is actually the hex view, but it's a labeled view. So this MZ is what's called the PE file signature. So this actually tells us that this is a PE file based off of this having an MZ as the first 2 bytes in a given file. All files, by the way, have file signatures. And this is one of the things that I try to tell people all the time, especially developers that are writing code for file upload capabilities and that sort of thing, is you don't want to rely on the .3 extension. Go in and look at the file signature, identify what the file is based on its file signature, and then work off of that. But you can see here that it's labeled, like here's the DOS header, for example, the real mode stub, which is what we saw before. It's got a bunch of other labels in here, everything in this sort of the tannish, peach, whatever you want to call that color. And then if we come all the way down here, we can even see that there are UPX headers in here as well. So there's our 1 UPX, 2 UPX, right? So we see 3 UPX. So it's been packed by UPX 3 different times. So it's done triple packing or whatever to try to make it further obfuscated. And then as we come down through here, we can see the rest of the hex view of the file. And if we keep going down, we come into the disassembly. And so here's the top-down disassembly and all this. But what's cool about this is that now, because we have these cross-refs, we can actually see where these strings are being used in the actual code. So this, like I said, is kind of a better value than just doing strings on your own or doing something like that. Now, IDA does this too, if it does find the strings. Now, by the way, I did not UPX unpack this file before running it in Responder. When I ran it in Responder, it automatically, because it's catching it out of the memory, it's already been, the operating system has already run that depacking section, and then it sent it into memory. So this is already grabbing that unpacked version out of memory, as opposed to looking at it on the file system and having to do the unpacking itself. This would also be true of any encrypted viruses. Virus code or any programming code, once it's, whether it's compiled or interpreted, it doesn't really matter, but it can't be run in its encrypted or packed state. Now, that's not to say that they can't have obfuscated strings or something else where they have other encryption built into it, but the actual instructions have to be clear text. This stuff here, these opcodes have to be clear, have to be understandable by the processor. You can't just submit compressed or encoded or encrypted or any type of thing. You can't submit that to the kernel. It doesn't know what to do with it. It doesn't know how to send it to the processor. Processor has no idea what to do with it, right? So these portions have to be clear text, which is why grabbing it from memory, which is what Responder does, and looking at it that way is a way better method of doing malware reverse engineering. And you can see things right off the bat, just looking at strings in here, for example. The IP address that's here, you know, the fact that there's a file name here. So without doing anything else other than just looking at the strings, we can kind of get a decent idea of where it's communicating to, files that it may drop, and that sort of stuff. So all of these could be used as IOCs, indicators of compromise, key risk indicators, whatever your tool says it is. And you can even use them as a basis of firewall rules. So you can just say, we're going to put in an egress rule that says block access to this IP address. You can put it into your IDS. You can create a snort rule or whatever IPS or IDS that you have to say that, hey, if we see anybody connecting to these, or if we see this IP address connecting inbound to our network, set an alert, right? And here's more IP addresses and those sort of things in here. So this kind of gets to what I was going to show you here in these slides, which is my levels that I consider of reverse engineering. So I consider that there are 4 levels of reverse engineering. And so the first one that we're doing right now, just looking at the strings and getting the information this way. The second one is the reverse engineering of an API call. Now, the reason why these are easy is because we can see that when they're called from an API, we see the actual function. So we can actually go to MSDN and look and see, what does this function do? What types of inputs does it take? What is the expected return value, and those sort of things. So we don't have to really kind of deep dive into the code to understand what that particular function is doing. The next level, the level 3 reverse engineer, they would have to do that, because when we look at author code, so for example, we go back over here to object. We're running out of time, Larry, and you can cut me off anytime you want, but these function thunks are all the API calls. So we can see where all those are, but these global ones, these are all of the authored functions. Now notice, by the way, that they have really boring names. They have subroutine, and then they have the offset they are in the file. So this is just telling us where we can find these subroutines, but it doesn't actually give us what the subroutine's doing. So this requires an additional level of understanding of the assembly code to be able to. That's weird. Why didn't this get moved? This is called the function preamble, by the way. I can explain function preamble to you too, but we're kind of running out of time.
Yeah,
but yeah.
But no, I don't want to interrupt you.
So,
like every other time, you kept me going. So please finish out that last, the 4th thing. What was the 4th?
Okay. So yeah, so the fourth one would be the full reverse engineering. So this would be like literally top-down understanding of the entire code. This is usually not required at all at the level for doing incident response or anything like this. The only people who are doing this level of reverse engineering are people that either want to maybe do a talk on it, write a white paper, or maybe they work for the government and they have to in order to reconstruct some sort of malicious code or something like that. But those are the only times that people are going to go all the way through to the level 4 full reverse engineering. But those are kind of the things. Like I said, I have an entire, and this, by the way, for your students, if they're interested, I'm actually, I've created this as a class, a malware reverse engineering class to do for Easy Counsel. They've tried to sell it a couple of times as a workshop, trying to see if we can get what gauge the level of interest that people have into maybe making this a certification class. But so far, 3 times that we've spun up the workshop, we've got such little response that they've ended up canceling them. And I think the main reason is because of this. People are intimidated by the assembly, right? And they're like, I don't know how to do assembly. I don't know what I'm going to be doing in that class, right? Like I said before, don't let this discourage you. If you are interested at all in doing malware reverse engineering, like I said, learning to read assembly is trivial. It's actually incredibly easy to do. And you should really just, I mean, like I said, just kind of dig into it. And I think the simplest way to first learn how to do malware reverse engineering, and this is how I do it in my class, is to write simple, like your Hello World program, right? Your first coding program. Write that, disassemble it, and then you can have that direct comparison of the high-level code and the low-level code to be able to see what everything's happening. Then just do like you would any other programming class. Move on to doing, you know, whatever your next program is. Usually it's like a number guessing game kind of thing, you know, with a user input, you know, prompting
So the first one's Hello World, right?
applying that. Right. And then, yeah, compile it, disassemble it, and then learn to see how to recognize those structures in the disassembly, and you should be good to go.
Mike, thank you very much. Do me a favor, for the students who want to contact you later, do you have something you can bring on the screen with your contact information that you show up? So if they want to take this class, about me.
Yeah, I mean, I can just give them my email address or whatever. But yeah, or I mean, hey, we can even do it as a you know, cyber kung fu class too. I have no issues with that.
No, not at all.
If you wanted to set up a malware class going through your outfit, that, I mean, I'm cool with that too. But the point is that it's just my name, michaelvien@gmail.com is the easiest way to reach me. I don't really have a slide up here with my contact. This is the only slide I have with my name on it. I suppose I can, but yeah, so. I mean, I have other emails, obviously my work-related emails.
Yeah.
But that should be
fine.
fine.
I have Internet Network Defense. It's so long. I give everybody Larry Greenblatt at Gmail. You know,
yeah, I have my magic
We're
wrist.
saying something that's really easy, and it's really easy to look at an assembler. It reminds me of I took Snort with Steve Northcutt, founder of Cien back in 2002, and you're looking at hex dumps. And all of a sudden, you know, now I'm just doing simple stuff. We're just doing, you know, packet headers and stuff. But you train your eye to look at things. And I yelled out real fast. I was like, oh, look, there's a 5 in that field. And he goes, isn't that weird? He said, now, when you're stuck in a meeting and they call upon you and you don't know what they're doing, they go, now, what do you think, Larry? Just say, oh, I'd have to see that in hex.
That's a good idea.
All right. Well, any questions for Mike?
I see a chat window.
Enjoyed it very much. Thank you. Yeah, when I met Mike, we were, and it was funny. They wanted me to teach CEH. I was telling them how the EC Council picked me to teach like the first version 7 and version 8 class, and I was like, I am nowhere good as like a Mike Vien or a Ralph, but maybe because I show up on time. I'm not sure why, but whatever the case is, great honor to meet you guys. and when I met you, I was just blown away. I was like, you know, I'm looking at packet headers. It's 20 bytes of information. You're looking at entire programs, you know, so I just think this is awesome.
Well, that's one of the things that I actually, I've been meaning to take a Wireshark class with you, because there's some stuff in Wireshark. I've been playing with some CTFs, and they have some PCAPs and stuff like that I can't seem to figure out. And so I was actually wanting to ask you about that kind of stuff.
Oh, well, I'd love to. I'm sure I could teach you a week-long class in about 2 hours.
Nice.
You've got enough background there. All right. Well, Tofi also enjoyed it. Great. Edio, Pradeep, awesome. Mike, again, thank you very much. We're going to take a break here, but I really appreciate it, and I look forward to the next time we hook up. Take care.
Absolutely. Yep.
Hey, guys.
See you, man.